So this is a nice question from limits. It's not so straightforward, and you can obviously leave it for the second go. So how we'll go about it is, so we are given a bound on gx. So we'll try to construct a bound of fx from that, fx times gx from that. So we are given that fx equals to root n when x is in 1 by n plus 1 to 1 by n. Notice that as n goes to infinity, so that is limit fx as x goes to 0, this is not bounded, right? So regardless, let's try to bound fx. So we are given that x is less than 1 by n, which gives us that root n is less than 1 by root x. That gives us fx is less than 1 by root x. We are given x greater than equals to 1 upon n plus 1, which gives us, so it gives n greater than equals to 1 minus x by x, which gives us root n is greater than equals to root 1 minus x by x, and thus fx is greater than equals to by x. So we have a bound for fx in terms of x. We have also, let's first evaluate this integral. We'll substitute, let's first evaluate the indefinite integral. We'll substitute t by sine square t. We'll get cos theta upon sine theta, and as t is sine square theta, dt becomes 2 sine theta cos theta d theta. So sine theta gets cancelled. We are left with 2 integration d theta, which is, so that becomes sine 2 theta by 2 plus theta, and using this, it is sine theta cos theta plus theta. Sine theta is root t, cos theta is 1 minus root 1 minus t, plus theta is sine inverse root t. So we have this indefinite integral, and we are to evaluate this from x squared to x, I believe. Yeah. So that gives us root x 1 minus x plus sine inverse root x minus root x square times 1 minus x square minus sine inverse x. This this integral evaluates to this, and on the other hand we have this is less than gx, this is further less than 2 root x. So we'll multiply both of these inequalities to get a bound on fx and gx. We get this multiplied by this becomes 1 minus x plus root 1 minus x sine inverse root x minus 1 minus x root 1 plus x times x sine inverse x. This is less than fx, which is less than 2. Now we are asked for the limit x tends to 0 fx gx. So we'll start by finding the limit of this as x goes to 0. So as x goes to 0, this thing goes to 1. This thing goes to 1 because sine inverse root x by root x goes to 1. And this is, this goes to 1. So this thing goes to 1. This goes to 0. There is no doubt about it. This goes to 0. And this thing can be written as root 1 minus x sine inverse by x times root x. This goes to 1, this goes to 1, this takes the whole thing to 0. So this also goes to 0. So the entire left hand side of this inequality, the left hand part of this inequality, or rather the lower bound of this inequality goes to 2. Then here we have limit x goes to 0 fg x, and here we have 2. So by sandwich theorem, so this limit will be 2. So the answer is C.